start?
Yeah.
Okay. Okay.
So I,
So,
I'm having two of the candidates today, maybe because of long weekend. So we can start, Bhaskar.
okay. Okay, fine. So, in last class, we started with interrupts, how we can have interrupts in Linux kernel, and we were discussing about how to register an interrupt for the given device, which is routed to processor using this interrupt number. So this is an API which is called from our device driver, and the parameters that we provide to this particular API is the interrupt number. This is a mapping of interrupt number to our processor. Then this is the interrupt service routine or the interrupt handler, which is triggered by Linux kernel, whereas interrupt is received or generated from the device. These are certain flags which define what is this handler and what is the type of this interrupt. Then what is the name? This is a name that defines the interrupt. So we can see these interrupts which are registered using using one file in proc file system. Let me just give you an example. Can you see my screen?
Yes, we can see your screen.
So now I am on Linux console. Is it visible or?
Not yet.
Okay, so
it's a bit slow.
So share.
We can see your slide number 7, hardware access Linux control.
Okay. So actually I'm only sharing my application. Let me share my entire screen so that you can see what I'm doing. Okay. So is it visible?
Yeah, it's coming. It's taking time though, but looks like it is coming up. Yeah, it's there. We can see your screen now.
Okay. Okay. So to check what are all the interrupts that are currently available and registered and active in the system, we can use this file /proc/interrupts. So if we list down these files, we can see there are basically 3 columns. Column 1 indicates the interrupt number. Column 2 indicates the counters. Counter means how many times this interrupt is received, and then the third column indicates the name of that particular interrupt, that what is which device driver has registered. So normally what we do is as a third parameter name here that we are seeing. In this parameter we give the device name. We can identify which device driver has registered for this particular interrupt number, and then the fourth parameter is a private information which is passed. It's a kind of memory address which is passed to the handler, and we can use this as a private information that we want to use in our handler. So this is how we can register interrupt and access the hardware. So like I said, there are 2 mechanisms in which we can communicate or get the data from the device. One is based on interrupt, the other one is based on polling. So what is the, so before we go to polling, we need to understand, do we actually require any other information apart from interrupt based handling of device. So one advantage you have with interrupt based mechanism is this is asynchronous. Asynchronous means whenever there is data with the device, it is going to tell the processor that it wants to communicate, it has some data to be processed. So that way, when we write the device driver, we only register the handler, and we let Linux kernel tell us, or the processor tell us that the device has the data and we can read it. So this way we don't need to monitor the device, and while the device is idle, that means it doesn't have any data, our driver could do any other processing which is related to Linux kernel, or Linux kernel itself could handle other devices or other user processes that are being created and that functionality is getting executed. The disadvantage with this particular interrupt based mechanism or asynchronous based handling of devices is, so let's say for example Linux kernel is currently doing a high priority task in the system, and like for example it is handling some high priority device which needs to be addressed first, and then rest of the devices could be addressed. Now in that scenario, if a low priority device wants to communicate with the processor, that means it has generated an interrupt. So what would happen is, since this is hardware based interrupt preemption, so processor will immediately stop executing the current code execution that it is currently doing, and then it will go immediately access this particular interrupt by calling the handler. So the delay that is created by this particular low priority device is going to affect the high priority device. So this is one example which we can clearly see that for low priority devices, handling through IRQ based mechanism is going to tamper the functionality of overall system. So if we have a such situation, then we don't go for request IRQ, even though it has a better advantage than polling. We go for polling mode. So what do we mean by polling mode is, at some frequent interval, what we are going to do is we are going to see the state of the device. Every device has some set of registers. When we read the status, we get to know what is the current state of the device, whether it has any data to be read or there is no data. So every frequency, the frequency is defined by our device driver. If we want to enable the frequency and we want to tell, we write the code in such a way that our device driver keeps on looking at the status of the device, and then it reads only when it has data. This functionality can be enabled or disabled by us, or it can be enabled or disabled by the Linux kernel itself. So in the example that we have taken, where there is a disadvantage with request IRQ, if Linux kernel is handling, every time Linux kernel is handling high priority device, it can stop